All right, so our last example for today, writing an equation from a graph. So the graph shows a parent function and two other transformations of that same function, g of x and h of x. Use the graph to derive their equation and write the function in a form that indicates the transformations of the parent function. So first step when you get to a problem like this where you're writing an equation of a graph is you have to identify the parent function. So in this case, we're lucky and we're actually given the graph at the parent function, but that might not always be the case. So again, that falls back on you really needing to know your parent function. So in A, we have the graph of f of x right here. So it's very clear to see that our parent function f of x is x squared. So now let's take a look at our first transformed graph, g of x. So looking at g of x, it appears that our function was shifted to the right 3 and down 2. So that means that we will have an h value of 3 and a k value of -2. And now we need to take a look to see, are there any reflections, any stretches or compressions? So there does not appear to be any reflections, so we don't have to worry about a -a or a -b value. And taking a look at the coordinates, we still have the same change from point to point. For example, if you're counting from the vertex, we're still going up 1, right, left 1, up 3, right, left 3. So there's no change in our rise or change in our run from point to point. So there are no vertical or horizontal stretches or compressions. So our only transformations here are a vertical and horizontal translation. So again, think back to that template. We have y equals a times f of b times x minus h plus k. So in this case, f of x is x squared. So we put that together into an equation and we get the equation of g of x is x minus 3, that quantity squared, minus 2. Because remember, it's always the opposite of h. And then the same as k. Now, taking a look at h of x, taking a look at h of x, it appears that we have a horizontal translation left 6. So we have an h value of -6 and a vertical translation of up 2. The vertex is the coordinate that you want to focus on when you're looking at horizontal and vertical translations for the graph of x squared. And now we need to check to see, are there any reflections, any compressions, any stretches? So there is definitely a reflection over the x-axis, which means our a value is going to be negative. And now let's see if there are any stretches or compressions. So we still have that same change in y over change in x, that same rise over run. This case, we're going down instead of up, but it's still down 1, right, left 1, down 3, right, left 1, etc. So the distance between our coordinates is not changing. So our a value is just -1. So we put that all together and we get -1 times x plus 6, because always the opposite of h, squared, and then plus 2, same as k. All right, looking at our next graph, b. So we have our parent function here, f of x. We have not seen this graph probably since Math 1. Maybe you did a little bit in Math 2 with exponential functions, but it's probably not been since Math 1. So if you get to a graph like this where you're not really sure what the parent function is, I think it's helpful to look at the coordinates. So if I'm really quickly looking at my coordinates of f of x, I have, it looks like 0, 1, and then 1, 3, and then 2, 9. So that means that f of x is 3 to the x power, right? 3 to the 0th is 1, 3 to the first is 3, 3 to the second is 9. So there's my parent function f of x. So now let's take a look at what's happening to f of x. And let's start with g of x. So when we're looking at exponential functions for horizontal translations and reflections, I think it's easiest to kind of take a look at where our x and y axis kind of shifted to, because that's what horizontal and vertical translations do, is they shift your x and y axis. So in this case, it looks like my x and y axis got shifted here. And I'm just looking at the shape of f of x compared to the x and y axis, and then g of x, where would the x and y axis be? So for g of x, we have a translation right 2, so our h value is 2. And then we have a vertical translation down 5, so our k value is -5. And now we need to look at reflections and stretches and shrinks. So taking a look at our graph, there is definitely a reflection over the y-axis, which means that our b value is going to be -1. And now looking at the change in points from coordinate to coordinate, all of that seems to be good. We still have that same change from point to point, so no vertical or horizontal stretch or compression. So we put this all together with our b, k, and h values, and we get the function for g of x is 3 to the power of -1 times x minus 2 minus 1. Or if you did want to have that negative value distributed in, you can. But I prefer to keep it in standard form, keep that b factored out. But you could distribute it in, and then it would look more like our examples that we just did, the practice that we just did. All right, so now let's take a look at h of x. So taking a look at where our x and y axis shifted, it looks like our x and y axis are now shifted here. So that looks like we have a horizontal translation to the left 4. So my h value is -4, and a vertical translation down 3. So my k value is -3. And it also appears that we have a reflection over the x-axis, which means our a value is negative. Taking a look at the change between point to point, there doesn't seem to be any sort of change, so no horizontal or vertical stretch or compression, so our a value remains just -1. So we put this all together and we end up getting the equation for h of x to be -3 to the power of x plus 4 and then -3.